Hello, my name is Nazeer from the Faculty of Civil Engineering Technology. Welcome to all of you in Canada, and for those international viewers, welcome to you also. What we are looking here is some calculus work. We're going to take the derivative of a product. So we're going to use the product rule. When we look at why this expression is a product, is because we have the x multiplying the binomial here, so that makes it a product. Say for instance, if there was not an x on the outside of this, this would not be a product necessarily. You could just multiply that out. I suppose we could still multiply this out and then do the derivative of that, but I want to show you how to deal with using the product formula and using the product rule. So when we look at this formula is telling us the derivative of product is equal to the first term, which is u, times the derivative of the second term, the first term, the second term, plus in between there the derivative of the second term, the binomial, multiplied by the derivative of the first term, 6x. Alright, so that's what it is. It's a pretty intuitive formula, so after you used it a few times, you should not need to look it up again. Okay, so let's go and perform the derivative of this, and we're going to use the same format that's there. And as we look at this, we see that we have the notation dy dx that represent the derivative of this expression. We're going to take the first term, place it there, and we're going to do the derivative of this. Well, to take the derivative of the inside of this bracket, 2 times 3 will be 6, reduce the power by 1, so you have 6x. And for this one here, you have a understood 1 there. 1 times 5 is 5. Subtract 1 from that, you'll get a 0 power. Anything to a 0 power is 1, so you'll just get 5. Right? We're going to put the plus sign in between, and then we're going to reverse the process. We're going to put the second term here, and we're going to take the derivative of the first term and multiply it. When we look at the derivative of the first term, it's going to be understood 1 times 6 will give you 6, and you subtract 1 from that power, make it 0, which brings it to 1, and that's what you have here. That is the actual calculus part of this, or taking the derivative of this. And of course, what's left here is a lot of algebra for us to do. We have to place our final answer in the prime form, or it cannot be reduced anymore. Let's go and multiply this out. This will be 36x squared, and this will be minus 30x, and 6 times 3 is 18x squared, and minus 30x again. So that's what it's going to look like, and then we're going to look for like terms after that. When we look at this, 36x squared minus 30x plus 18x squared minus 30. Remember, like terms could have different coefficient, but the power has to be the same. The variable and the power has to be the same. So when I look along here, I could see that 36 and 18 are like. Minus 30x and minus 30x are like too, because the variable have the 1 power, and these two have a square term, right? So we could put these together fairly easily. We are going to have 54 for that, and 54x squared, and then we have minus 30 and minus 30 minus 60x. Now you would tend to leave, some people tend to leave it like this, but it could be factored. When we look at this here, I see x and x in both, so we know we could take out an x for sure. And when we look at this and this, 6 could go into both of these. So let's see what we get from that. If we were to pull out a 6x, 6 into 54 will give you 9, x into x will just give you x, and 6 into 60, x will give you 10. You could multiply back this out, you'll get exactly what's here. But this would be the prime form. This would be the derivative of this right here, this term, this expression right here. Okay, so not too bad, not too bad. Let's do another one though. Let's do another one. Let's continue. We have a trinomial times the binomial in this case, and both we're going to leave it as as a product rather than multiplying this out and then do the derivative. We're going to use the product rule. We're going to use the formula. The formula doesn't change, right? It's saying take the first term, multiply by the derivative of the second term, put a plus sign in between, take the second term, multiply it by the derivative of the first term, and that's the derivative of that. And the rest of it would be just algebra. Let's go to the, and we have to be very careful to carry our notation with us, right? I'm taking the first term, placing it there, derivative of the second term. So derivative of a constant is 0. When we look at this guy here, 3 times minus 2 is minus 6, reduce it by 1, 6x. So that's what we're having here. 3 times 2 is minus 6, and I'm going to reduce it, so 6x squared, right? So this will, I have elaborated a little bit here to show you how the power comes out. Okay, I started out with 3, I subtract 1, I'm going to get 2. The next step will show us that. I'm going to take the second term, place it in this position, and multiply it by the derivative of the first term. When we look at the first term, it's a trinomial, so it has 3 terms. Multiply by 4, so 4x cubed will be there. 4x cubed. This one here would be a minus 6x. Minus 6, and to the first power will be x. And we have a constant which will be 0, and right there. Let's go to the next step. We are just going to clean this up a bit. We have some multiplication to do right in here, and again right in here. So we're going to multiply all of this. It's best to go minus 6x squared times x to the 4th will give you minus 6x to the 6th, and this one will be a plus 18x to the 4th, and this one will be a minus 18x squared. And then we're going to go and expand this also, and then look for like terms. And this is what we're coming out with. And when we expand this, 1 times this will give you this term here, and 1 times minus 6x will give you that, and minus 2 times 4 will give you minus 8x to the 6, and minus 2 times minus 6x minus 2x cubed minus 6x will give you minus plus 12x to the 4th. Okay, and now I am going to go and look for like terms. I'm going to start off with the highest power. When we look at this, I see nothing larger than 6. This one is a 6 again. Nothing larger than 6. So these two are like terms. 8 and 6 is 14. I'm going to have 14x to the 6 minus 14x to the 6. When we look at the next largest term now, and I'm seeing it's to the 4th power. So I'm going to have 30 with these two guys here, and then we're going to have just the 4x cubed, and then we're going to have to put together, is there any other x squared? No, I don't see any other x squared. Okay, so the next step to this is just adding up terms. So we have 14, we have 30, we have 4x cubed, there was nothing else to go with that, and then we have x squared. There was nothing else to go with that either. And the last thing that we had left was a minus 6x. We place it there, and we look for factoring now. Is there a common factor in this? When we look at this, we have 2, we have even, 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 and even. So we know that we could take out a factor. We have x's in all of them, so we know we could pull out an x from that. The thing is, what is the common factor for the coefficients of this? And I would suspect it's going to be a 2. 2 could be pulled out, 4 cannot be pulled out. And you go with the lowest power, so we pull out a 2x. 2 into minus 14 will give you minus 7x, and you reduce that by 1 because this, when it multiplies back out, it'll give you exactly that. And 2 into 30 will give you 15 and reduce the power by 1. And 2 into 4 will give you 2, reduce the power by 1. And 2 into 18 will give you minus 9, reduce the power by 1. And 2 into 6 will give you 3, reduce the power by 1. So that'll be just 3. And that's how you use the product rule. And I hope that you like the videos. If you do like the video, hit the subscribe button and give me a thumbs up. Thank you very much. Have a great evening, weekend, or whatever. Bye bye.